Hello and welcome to Saturday's vlog. Today, as usual for the last few Saturdays, we're going to take a look at the Killer Sudoku, the deadly rated puzzle that appears in the Times, and we'll see how we get on and whether we can find some good logical ways to complete it. Hopefully you can see the puzzle there on the screen. I'm just going to pause the video now while I fill in the very obvious 2, 3 and 4 letter combinations. Okay, there are two cells that we need to focus on immediately, as we can see. The first is this one in the bottom left 3x3 box, where we know that the box needs to add to 45. We have a 22 box and a 17 box entirely contained within that 3x3 box, and the sum of those is 39. So we know this must be 6. So let's fill that in. And in fact, I spotted that we could fill the 7, 8, 9 in as well in the 30 box with 4. And in fact, there's a few things we can do here. Because we now know that these 3 cells in the 30 box add to 24, and we know we also have 2 8 boxes entirely contained within this 3x3, we know that this must be a 5. So let's fill that in. And that again, I mean, this is another of these puzzles that's being very helpful to us early on. We know this 8 here can only be 1, 2, 5 or 1, 3, 4, and as we already have a 5 in the box, we know it must be the 1, 3, 4. So let's put that in. Oops, I think I just put 2 by mistake. 1, 3, 4, 1, 3, 4, and that means that this must be 2, 6. When I was solving this puzzle, I'd always be looking here, by the way. I now know there's a 6 in this first row, in one of these 2 positions. And I've got a 6 in this box, so I'd always be scanning upwards just to see whether there's anything obvious that I can immediately deduce from the fact there must be a 6 in one of these 3 cells. I can't see anything immediately clever. So let's move on to the other thing I noticed straight away. And that's the importance of this cell here, which again we can isolate the value of. The way we can do that now is that we have this 5. We know therefore these 4 cells add to 21. These 3 cells add to 12, so these cells altogether add up to 33. Therefore these 2 cells have to add to 12. And therefore this cell must be a 6. Okay, and there are a couple of other things I'd want to note here. So I'm going to do that. In particular, in this 18, which we know has to sum, these 2 cells have to sum to 12. But the 6, 7, 8, and 9 are ruled out of this cell. So this cell can only be 3, 4, or 5. And this cell can only be 7, 8, or 9. And the reason I think it's important to note that is you can see perhaps a pattern developing across this top row here where we already have 5, 7, 8, 9. So I only have to get one more cell that's limited to 5, 7, 8, and 9 in this top row. If I was to find such a cell, those 4 cells would then be complete in those 4 numbers, and I could rule them out from being in any other cell in the line. The other thing I'd want to note is that if we look at the first row, we can see we've got a 26 box, an 8 box, and a 22 box, with only this cell and this cell sticking out from the first column is what I meant to say. Only this cell and this cell stick out in that first column. So if we add 26, 8, and 22, we get 56. So we know that these 2 cells must add to 11 somehow, in order that the first column can equal 45. Now, 11, you can still do it in a couple of ways, but the 3 and the 4 that have already been used by the 8 box here, I mean, there are very few ways this works. One way is 2, 9. That seems to be completely unrestricted. And the other way is 5, 6, but 5, 6 only works if the 6 is at the top and the 5 is at the bottom. because of this 5 here and this 6 here. And with a little bit of work we can see that actually a 2 is impossible in this cell, because we've already got an 18 and an 8 in this row, so that's 26. So we know these 3 need to add up to 19. But if this is a 2, this would be an 8 and a 9, this would be an 8 or a 9. And that's impossible because 7, 8, 9 can't appear in the third column. So this isn't a 2, which means this isn't a 9. And similarly, we can look at the 9 here, and the 9 can, I think, only be made in 2 ways now because the 6 is ruled out. So we could have a 5-1-3 combination, that's possible, or we could have a 4-3-2 combination, that's also possible. And something you'll note from both of those is they both contain a 3, and therefore this can't be a 3, so we should eliminate that possibility too. And in fact, this last step, I think, is what was necessary to break the first really difficult logic stage of the puzzle open, because we still need to place a 1 and a 2 in row 1. But we know that we can't put the 1 and the 2 in the 9 box, because if we put them both in the 9 box, the other cell would be a 6, which is impossible. And therefore, we know this cell must be a 1 or a 2. Let's fill that in and see what that means. Well, we can see immediately it can't be a 2 because we already have 2 in column 1. So all that work tells us this is in fact a 1. Let me just put that in. Which means that the 9 actually has to be 2, 3, 4. And that means that this cell must be a 5. And this is a 7. Which means there's no 7 here, and no 7 here. And no 5 here. And another little point that we can immediately note, if we look at the 26 box here, which is already got a 1 and a 5 in it, we can see that the other 3 cells need to add to 20. Well, let's imagine this is a 6. Therefore, these 2 cells would have to add to 14. Now, that's now impossible. So the only way of making 14 in 2 cells is a 5 and a 9, which is impossible, or a 6 and an 8, which is also impossible. So this cannot be a 6 and must be a 9. So let's fill that in. We now know that must be a 2. And yeah, it's quickly going to, I think, become fairly straightforward from here. So we can see that the 2 in the top 3x3 box here is locked into one of these 2 cells. So we should note that. Which means that the other 2 cells must add to 10. But there's only one way of doing that, and that's with a 4 and a 6, because we can't have 1, 9, because we already have a 1 and a 9 in the box already. It can't be 2, 8, because we already have a 2 in the box already, and you couldn't have a box that was 8, 2, 2. Can't be 3, 7, we already have a 7 in the box, so it has to be 4, 6, and you can see that there's already a 6 in column 3. So this must be a 6 after all of that. Which means this is 2, 4 in some combination. Oopsie, sorry, didn't mean to do that. Oh dear, hang on, I have to work out how to unwind that. There we go, 2, 4. 2, 4, which means that this is 3, 8. This is 3, 8. You can see that means that 22 here, it's already got a 4 and a 7 and a 9 locked into this box, which sum to 20. And that's, you can see immediately that, you remember when I mentioned that these 2 cells here had to add up to 11. But I've managed to put the 2 in the wrong box there. That should be a 2 there. So let's just correct that. That one we don't know about yet. But we didn't use that logic in anything else, so it shouldn't actually affect anything that we've done, in the sense that it didn't, nothing relied upon it to that point. So fortunately for us, I think we can still continue on, and it should still work. Let's see. It's got to be a 4 now. Let's remove the 4s here. And I'm just going to correct this. So this is 5, 8 in some combination, isn't it? Like that. Which means this is 1, 3. And this is 1, 3. And we can use the logic we were using earlier with the 18 and the 8 in row 3, adding to 26. Plus the 9 here is 35. So we need these two cells to sum to 10. And you can see that only one way. There is only one way of doing that. That must be the 8. That must be the 2. That's a 4. And that's a 3. Okay. Now a quick look at column 9 can give us some more numbers, I think, because we already have a 21, which means the other 4 cells need to add to 24. Now if we selected this cell and said, well, let's make that the 7, okay, you can see how that would force 3 of the cells to be 7, 8, 9, but we've still got another cell to fill, so that's absolutely impossible because that cell would have to be 0. So this cannot be a 7, this would have to be a 5. Okay, I just filled in some notes on the 16 box there, nothing interesting. The next thing that I think that might be interesting though is to just take a look at row 8 and the 21 here. And the reason that we should focus on this 21 is that we have 2 cells on the left hand side that already contain some reasonably high numbers. So we've got 7 and a 9 here and a 5 and an 8 here. And when combined with the 21, it should be fairly obvious we can't have these numbers to be too high. Because if they are, we won't actually be able to fill in the other 4 cells. I mean, the minimum value we can make these 4 cells, this one, this one, this one, and this one, is 10. And that would be if they were 1, 2, 3, and 4. So we know that the maximum value we can have for the 21 plus the 5, 8 square plus the 7, 9 square is 35. In other words, these cells here cannot sum to more than 14, otherwise there's a problem. Now if we were to select an 8 for this cell, that's, you can see you're either going to get 15 or 17, so you're going to break that condition. So this must be a 5. Okay, it's still possible, I think, for this to be a 7 or a 9. And we could do a little bit more work with this 21. For example, if this was a 9, then the only way of making 21 with 3 cells is the 6, 7, 8 combination. And in fact, that's quite restricted here. This would have to be the 6, because it can't be a 7 or an 8, because the 7 and 8 is already used in the bottom right 3 by 3 box, which would mean these 2 cells would have to be 7. So let's just fill that in as a possibility and ask ourselves what would happen if instead this was 7. So now we've got to make 21 again, and I think I'm right in saying that the only way of doing that is 984, because I think anything else won't work. Let's just check that. So 966 obviously won't work, and 86, that doesn't work either. So so 984, again, that would mean this would have to be the 4, and this time this would be the 9. So let's put that in, because it severely limits the possibilities. And the reason this is important is that now the 7, 8, 9 are locked in terms of row 8. So we know that this cell and this cell can only be 1, 2, 3, 4, 6 would be the possibilities for each of them. In fact, this one's even more restrictive due to the 6 in row 7. Sorry. So this could only be 2, 3, 4, 6, I think, which means this can be 3, 4, 1, 5. And similarly, there are very few possibilities for this cell. We can see the logic earlier. We need the 4 cells that aren't in the 21. in column 9 to add up to 24. So 9, 8 and 5 would be 22, which would make this a 2, which is impossible. So in fact, that means that this cannot be an 8-9 combination, and this has to be a 7. So let's put that in and see if it helps. 7, this can't be a 7. Really limits what this can be now, because we know that this either has to be 3 or 4. And the next thing I'd note here is just to take a look at this box here where the cursor is, the 3x3 here. And you should be able to see that there are only 2 cells sticking out from this box. There's this cell here, and there's this cell here. And in the cell that's highlighted at the moment, there are a limited number of possibilities, a 4 or a 6. And in this situation, we can immediately deduce that this cell can be limited to 2 possibilities also. And that, it's fairly straightforward mathematics behind that. I mean, if we take, let's imagine this cell was a 4, then these 2 cells have to add to 17, plus the 16 is 33. These 3 cells would have to add to 12, so this would have to be a 9. And similarly, just working through, if this was a 6 instead, it would be 15 plus 16 is 31, this would be 14, and this would have to be a 7. And perhaps unluckily, or perhaps by design, that's not the way to make further progress here, but you can see how you need to spot that sort of thing, because had that, for example, yielded a 6 in this position as one of those 2 possibilities, that could immediately have been ruled out, and that would have given us another number. As it is, I can't see it's giving us anything that helpful. Once one gets to this sort of point, it's just worth pointing out that the way to make progress is to be able to ask the right questions, to prove or to make logical inconsistencies appear in the grid. So again, what I'd be looking at here is this cell. And we know that there's 1, 8 here. And we know that the other way of making 8, if you like, in row 3, i.e. the way that isn't with a 2, 6, because that's already ruled out, must appear within these 4 cells for the 18 box. So that means there has to be either a 1, 7 combination or a 3, 5 combination within this 18 box. That's absolutely forced. Now, because of that, and because I already have a 5 and a 7 in the 29 here, that means that these 2 this cell here must contain that 5 or a 7. I don't know which, but I can't have this 8 combination entirely within this box, because it's ruled out, because the 1, 7 and the 3, 5, which are the only possible left combinations for that 8 sum, cannot appear wholly within the top right 3x3 box. Now, that's interesting as well, because if we look at we know that this 9 here contains a 4, but we don't know quite where that 4 is. But we now know that it can't be in this position, because if it was in this position, a 4 would have to appear in one of these 3 cells, and that's impossible because you can't have a 4 and an 8, because that would become 2 4s. So in fact, this cannot be a 4. That locks the 4 of the 9 into this middle 3x3 box here. I'll have to label these boxes at some point so we have some consistent sort of notation. Maybe this would be box B, this would be box A, B, C, etc. And we'll do it that way. Okay, and this is, I think, the point where the other difficult step of this puzzle comes in. And it really relies on you being vigilant and experienced, I think, regarding where to place certain numbers and asking yourself the right question about where numbers can go. And I'll explain what I mean by this. I've been looking for a while at column 7, and I want to place, I know I need to place a 5 somewhere in this column. And 4 cells, I've ruled out the possibility of there being 5, and in fact this cell also cannot be a 5 because of the 5 that's already in this box. So we know that there's a 5 in one of these cells, and in fact we know it can't be in this cell because of the 5 here. So we're left with 3 possibilities for a 5, and you can see where I'm going with this. I want to try and place the 5 in the 9, because by doing that I've isolated the values of this 9, and that's obviously going to be very helpful. So we're left with the question, can this square here be a 5? And in fact it can't be. And the reason you can establish this is you can actually look at row 6. And in row 6 we can see that we can't place a 5 in any of the first 4 squares. And in fact we can't place a 5 in this 10 square either, for obvious reasons, because then there would be 2 5s in there. So we know that the 5 in row 6 appears in this row. It therefore doesn't appear in this cell. Okay? Therefore, in this column, in column 7, I know that my 5 is in one of these 2 positions. I can't quite tell that it's here yet, but I know it's in one of these 2 positions. So let's fill that in our notes and see if that helps. And you can immediately see it's going to help because it instantly locks this cell to being a 6. So let's put the 6 in now, which means that this cannot be a 9. This cell here cannot be a 6. Therefore this can't be a 1. And in fact, the whole thing is going to crumple now, because this now must be a 9. And this must be a 7. And you'll remember that we looked at what's this going to be? Is it box H in our new notation? And we noticed that this cell and this cell are linked. And the fact that this is a 6 means this must be a 7, I think. Let's just quickly check that for D7. Yes. Let's put the 7 in here, which means this can't be a 7. And now, if we look at column 4, we can see again that we're going to really struggle to place high numbers in this column. There's very few places left where we can put any high numbers. Where can we put an 8? We can't put it. We could put it here. We can't put it here. We can't put it here. Can't put it here. Can't put it here because of this 8 here, and we can't put it in either of the last 2 cells. So actually, this is an 8. And if we can't place an 8 anywhere apart from there, we definitely can't place a 9 anywhere apart from here. So let's put the 9 in. Okay. And because we've got the 6 now locked in this position, it can't now be here. And it must be here. So let's fill that in with a 6. Remove the 6 here. Oh, sugar, sorry. Okay. And now you should be able to see that this cell in fact can't contain, because it can't contain a 4, 5 or 6. This can only be a 1, 2 or a 3, and in fact it can't be a 2, so it must be a 1 or a 3. And therefore this cell here must be a 4. And I think the puzzle is now broken, i.e. we've broken its back. There isn't going to be anything clever left to do. So I'll put the music on as I finish it. I hope this has been interesting. I think this was quite an interesting puzzle. There were 2 stages or 2 steps at quite different points where one needed to have a bit of inspiration. So I enjoyed this one, and I hope this analysis has been helpful. And we'll see you again soon.